Today we're going to start talking about electric circuits. And to talk about circuits, we first need to introduce current. So current is the flow of charge. It's basically electrons moving with their electric charge and creating a current. So circuits are the study of current in its applications. So let's write that down. So you might have seen that circuits are drawn as lines that are connected to each other and that have different symbols that represent different things. So today I'm going to tell you what each symbol represents. So when you have a straight line that has nothing else in it, it's a cable. So this is a cable. When you have a line, but it breaks and has a line that goes up, this is a switch, which can be connected or disconnected. So it can be a closed switch, which creates basically a cable, or an open switch, which means that no electrons can pass from this side to this side. We also have resistors. Resistors are drawn as this zigzag line. They are this thing that you can put in a circuit and it decreases the amount of current that passes through. So the higher the resistance of the circuit, the less current will pass through it. We also have lamps. They can be drawn like this. And what every circuit needs to have in order to have energy and current flowing through it is a battery or a cell, and it's drawn like this. So this basically means the positive end of the battery and the negative end of the battery. When you have a battery or a cell, charge is actually flowing between the terminals. So it flows from one place to the other. So let's draw a couple of circuits and see what they mean. So first we have something called a short circuit, cortocircuito. It looks something like this. There's a battery. You don't always have to put the positive and negative, just the lines. And it's closed. There's nothing else. So that means that the energy is coming out of the battery and back to the battery without having any resistance or anything that's using it up. So that's going to create probably a fire, an explosion, because you're connecting the terminals of a battery to itself. So never make a short circuit. When that happens in a device, the device will probably get damaged. So let's make a circuit that is not a short circuit. Maybe we have a battery, and the battery gives energy, loses some charge to a resistor, and then passes through a lamp and lights up the lamp. When this circuit is connected, the light is going to light up because there's energy being given to it. And this is not a short circuit. And you could draw this circuit in many different ways. As long as the positive terminal gives energy to the resistor and then to the lamp and comes back, you can draw it however you want. You could put the battery in the opposite direction. You could put the resistor here perpendicular. You can put the lamp here. And then instead of making it like a square, you can come back as a circle. These two circuits are exactly the same thing because this is just cable. And it's usually drawn with right angles just because that's how circuits are expressed. But it doesn't necessarily mean anything. This corner doesn't mean anything because it's just cable. So you could draw it like this if you wanted to. Now we have two ways of connecting things in a circuit, in series and in parallel. So in series means something like this. So here we have three lamps connected in series, and what that means is that the current that comes out of the battery, the same current that passes through the first one, will pass through the second one and through the third one and come back. So basically, the same current passes through all of the components. But we could also connect three lamps in a way called in parallel. So it looks like this. circuit has the same components as the circuit on top. It has 3 lamps and 1 cell or 1 battery. But the current here can decide which branch it takes. So each of these things is called a branch. Here we have, for example, branch 1. This would be the second branch. And this would be the third. So basically, when the electrons come out of the battery, they're going to come out and they can choose how many go through the first branch, how many go through the second branch, and how many go through the third branch. And the electrons choose this because they try to choose the path of least resistance. So electrons don't like to make an effort to pass through something. So if there's a path that is easier to travel through, the electrons are going to choose that path. In this case, each branch is exactly the same. So 1/3 of the electrons will choose the first one, 1/3 will choose the second one, and 1/3 will choose the third one. So there will be the same amount of electrons in each one. And in the end, they will all come back together, join, and go and get back into the cell. Now, what happens if you make a circuit in parallel where you have resistance? For example, lamps and resistors are resistance. But then you have another branch where there's nothing. Which path do you think the electrons will choose? Will they pass through the resistance or will they pass where there's nothing? Well, of course they'll pass where there's nothing. So basically the electrons won't see the resistance because they'll just go through the outside where there's no resistance. So basically this is also a short circuit. So if you connect this circuit, you're going to cause a fire, because electrons see exactly the same thing as this, because they don't see this path of a lot of the resistance if they can pass through somewhere that has basically no resistance at all. Now let's talk more specifically about current and voltage, the two things that we care about inside a circuit. So current, as I had said, is the flow of charge in time. So what you need to know in order to calculate the current is how much charge was moving and in how much time. So basically the definition of current is equal to charge over time. So current, we're going to express it with the uppercase letter I. Charge, we call it Q, as in last class, and time, as always, is T. So this is the equation for current. We always calculate current dividing charge by the time. Now, we know that the units for charge are coulombs, C, and the units for time are seconds. So the unit for current is coulombs per second, but this has a new name. It's called A, the letter is A, and it's called amperes. Amperes, or amps. So this is the unit of current. Now voltage we also mentioned last class. Voltage is the amount of energy that each charge gains when it comes out of the battery. So we can define voltage as energy per charge. So voltage we write as a V, energy we write as an E, and charge we write as a Q, like up here. So this is the equation for voltage. Voltage is energy over charge. And the unit of voltage is going to be determined by these two. So energy, we always give it in joules, and charge, we always give it in coulombs. So the unit of voltage, which is actually called volts, is going to be joules per coulomb, and it's called volts. So current is the amount of charge. So it's talking about basically how many electrons are going around the circuit every second. So this tells us the number of electrons. And voltage tells us how much energy does the battery give each charge. So if you have a 9-volt battery, that means that the battery is giving 9 joules of energy to every charge. And we have two words to express voltage. We either call it voltage drop or potential difference. So this is voltage or potential difference. It means the same thing. It's just two words for the same thing. And let me mention something real quick about electricity, which is electric power. Electric power is defined as the voltage drop times the current. So voltage drop times current. So the equation for power, which we call P, is voltage V times current I. And the units of power are actually watts. We've seen power before, so it can be defined as joules per second, as we had defined it before in previous years, or according to this equation, the unit watts also means volts times amperes. And this actually makes sense, because volts is defined joules per coulombs, and amps is defined as coulombs per second. So this cancels out and gives joules per second, which we had already defined before as watts. So with electricity and electric circuits and everything, when you're buying an electric appliance, you usually care about its power, its watts, because it tells you how much work it's going to be able to do per second. So there are actually two other components that a circuit can have, and they're called ammeters and voltmeters. And they're drawn like this. So an ammeter is drawn like an A inside a circle, connected to the circuit, and voltmeters are drawn as a V inside a circle, connected to the circuit. So these are called ammeters, and these are called voltmeters. And by the name, because of the name that sounds similar to the units that I just told you, you can guess that ammeters are components that measure current, and voltmeters are components that measure voltage. When you want to measure current, you have to put the ammeter in series with the circuit. So in series meant that it's in the same branch, and all the current that passes through the object passes through the ammeter. So this has to be connected in series, so that the same current passes through the ammeter. And voltmeters instead have to be connected in parallel. And we'll see why in a second, but basically when the voltmeter is connected in parallel, it feels the same voltage drop as the component that you're trying to measure. So let's do an example. Suppose you have this circuit that is made up of a battery and a resistor. And that's it. And you want to figure out the current flowing through it with an ammeter and the voltage drop in the resistor with a voltmeter. So what you need to do is connect, as is expressed here, the ammeter and the voltmeter separately. So first you want to connect the ammeter, and you need to connect it in series. So that means in the same branch as the resistor. So you would have to open the circuit up here and put your ammeter right here to measure the current. So with the ammeter in series, you would get the current. Now, if you wanted to measure the voltage, so let me draw it again, you can't connect it in series. You have to connect it in parallel. So that means making another branch with the voltmeter. So that means something like this, making a branch with the voltmeter, and that'll give you the voltage around the resistor. Right, so that's the way to measure current and measure voltage in a component. Now let's move on to the circuit rules, the rules that a circuit always covers that tell us what the current and the voltage can be when we analyze a circuit logically.